All right. Good afternoon, guys. So today we'll see OSPF. What is OSPF? Open Shortest Path First. Okay. Then its protocol number is 89, and then AD value 110, and it uses Dijkstra algorithm. And then it is open standard. It is open standard, and here we are using process ID. Instead of in your EIGRP, what we are using? AS number. Here it is process ID. And what is the process ID ranges? Again, 0 to 655. Sorry, 1 to 65535. Okay. And then here we work on area concept. Area. We see area concept in your OSPF. Okay. And then we have multicast address. Multicast address, that is 224.0.0.9 and 224.0.0. Sorry, 224.0.0.5 and 224.0.0.6. 5 is for all routers and 6 is for DR and BDR routers. What is DR? Designated router and backup designated router. OSPF is a very complex topic, I would say. A lot of things are there to learn. Okay. So we say 7 LSAs, link state advertisements. Okay. 7 LSAs are there in your OSPF. But in your CCNA level, we are only seeing 2. Okay. We are only seeing 2. Router LSA and network LSA. Very basic thing. We just show the practicals and we show, okay, this is the LSA, this is the LSA. But in your NP level, you will learn multiple things in OSPF. Okay. Right now, in your enterprise level, we are working on EIGRP and OSPF only. Okay. So how does this area concept works? How does this area concept works? Means, see, in your EIGRP, we had multiple routers like this, correct? And they are all connected to each other and they are all configured on same autonomous number system, correct? That is your EIGRP. Whereas in your OSPF, how it works means they work on area concept. So first 3 inside this organization, this first 3 routers will be configured as area 0. Okay. And this router is configured as area 1. This is configured as area 2. Likewise, we divide the routers into areas. So that what will happen? The traffic will go to only the particular area. Not every area is going to get the traffic. So this is how we are going to divide the network traffic in under OSPF. This is called the area concept. So in an organization, you will have multiple routers, and in that multiple routers, certain routers are connected as area 0, area 1, area 2, area 3, and accordingly. Okay. And also, area 0 is called as the backup. So here, another point I'll give you. See this, what is DRBDR is important concept. I'll show you in practical very clearly. Okay. Now just write it down. Okay. Here, area 0 is called as the backbone area. Okay. And every area must have a virtual link connected to the area 0. Okay. And we have something called ABR router. What does this ABR router means? See, I have a topology like this, correct? So here, this is the backbone area 0. So what is going to connect this area 0 and area 1? So there will be a router in between. Okay. So this side of the interface will be connected to area 1 and this side of the interface will be connected to area 0. So this is called ABR router. That means area border router. Okay. Likewise, so but here I've given a point. Every area must have a virtual link. That means, see, area 1 is directly connected, but area 2 is somewhere here, right? It is connected like this. It is not connected with area 0. But the routers which are in area 2, one interface must be connected to area 0. One interface must be connected to area 0. So this is called virtual link concept. We say virtual link concept. Okay. So this you will learn in detail in CCNP, but I'll give you a short description so that you'll understand better when you go to CCNP. Okay. So this is how it will be. So every other areas will be connected to area 0. That is mandatory. Any area. How they are going to connect? Because they are not directly connected with routers. Correct. So virtually they will be connected to area 0. So that is called a virtual link concept. And the router which is going to connect the area 0 with other area is called the ABR router, that is area border router. Write down for ABR router. ABR router, area border router. Area border router. The router under OSPF, the router, the router under OSPF, which one interface is in area 0 is called ABR router. The router under OSPF in which one interface is in area 0 is called as ABR router. Under multi-area, next point, under multi-area OSPF, under multi-area OSPF, each and every area, each and every area must have their link with area 0. Must have their link with area 0. Written? Okay.
But area also is connected to area 0, right?
Correct.
So all area 1 and area 2 is connected.
It doesn't matter if it's connected to area 0. What is area 0, I said? What is the point I've given now? Under multi-area OSPF, the router which is connected to area 0 is called as ABR router. If it's connecting between area 1 and 2, that is not our concern. Because area 0 is the backbone area. And we are concerned about the area 0 only. So every other area should be connected with area 0. And the router which is connecting other area to area 0 is called as the ABR router. So you will have multiple ABR router. Why? So area 1 and 0 you are connected. If you are having area 2, again that router should be connected with area 0. So that is a ABR router. So these kind of things you will learn in your CCNP. Okay. All right. Before that, okay, you written all these things. One small practical is there. Very simple practical. I'll show that small practical. And then we will learn the in-depth technical knowledge of OSPF. That is very important. Okay. So I've taken 3 loopbacks. Okay. And then 2 networks. Done. Dot 1 dot 2. Eleven dot 1 dot 1 dot 1. Three slash 0. What is IP? 11 dot 1 dot 1 dot 2. Correct. Interface loopback 1. IP address 3 dot 3 dot 3 dot 3. Dot 0. Okay, now done. So I'm going to do the OSPF. Here I'm going to say router OSPF. So you give a question mark process ID 1265535. Process ID can be same and different also, it doesn't matter. Okay, but in your EIGRP, autonomous system number must be same on everything. So here we are segregating by areas, not on process IDs. So process ID will say 1 year. Okay. And then, and your OSPF is classless by default. It is what? Classless by default. That means it supports VLSM. Okay. So here, what command is not required? No. No auto summary command is not required here. What is your name? No. Hemant. Hemant has yawned for 6 times now. I've been counting. Correct, Hemant? Yes. So I'm always not into networking. I watch everyone. I've been counting him. 1, 2, 3. Couldn't control. You know what he's doing? He's going like he's doing this. You didn't sleep, Hemant. Weekend party. Okay. So no auto summary command is not required. So directly I'm giving network. So what is the network? I'm going to give the directly connected networks 11.1.1.0. Correct. And then here I'm going to give the wildcard mask. So just opposite of the subnet mask so that this particular network only advertise it. So it is 0.0.0.255. Okay. Just like your EIGRP, but after that one important command we are giving, that is area 0. Okay. So here everything we are in your CCNA level, everything we are working under single area 0. Okay. So I've given this 11.1.1.0 and then we have 3.3.3.0. Correct. That's it. Now go to R1. So router OSPF1 network 11.1.1.0. Correct. 0.0.0.255 and area 0. And then you have 10 also connected. And then you have 2.2.2.0. Okay. So this neighborship has formed. What is this neighborship? I'll show you. Router OSPF 1 network 10.1.1.0, 0.0.0.255 and area 0. And then you have 11. And then you have 1.1.1.0. And then now say ping 3.3.3.3. Okay. So ping, I'll say do ping. And physical interface 11.1.1.2. That is also pinging. Okay. So this is how you can do the OSPF basic level routing. Okay. So this is just basic. Now important topics I will teach you. You can, meanwhile, you can write just write down these comments. This much you can write down.
That area ID, we have to select 0 only.
Yes.
Oh.
Because here we are learning only areas here.
And that network ID of network ID, we have to give off that directly connected only.
Yes, yes. Just like your dynamic routing protocols, RIP version 1, RIP version 2, EIGRP, like that only.
Previous
Yes, yes,
protocol.
yes. Written, guys? Okay. Here you have OSPF. OSPF is open shortest path first, and it is a link state protocol. That means it is based on bandwidth. Okay. And then it works on protocol number 89, AD values 110. The important thing in is your OSPF is you have two multicast address. Okay, this concept has to be very clear. Then only you will understand OSPF clearly. Okay. I'll teach you that. So 224.0.0.5 and 224.0.0.6. So in an interview, they will ask what is the multi-class address of OSPF. Then you say 0.5 and 0.6. So who will use 0.5 and who will use 0.6? Next question. You say all routers use 0.5 and DRBDR will use 0.6. They will ask you why we need DRBDR routers. Okay, how it is going to limit the mesh adjacencies. So likewise, they will keep on asking questions. Initially, they'll start with simple question, what is multicast address? That everyone will be able to answer. If there are 30 students in my class, and all 30 students will answer that question, no doubt about it. But how you're going to explain that, why it is required? There only they will filter you in English, in the interview. Okay? All right. Before that, quickly write down this DR election, BDR election, and router ID and router ID selection.
Have you guys received batch maybe to your mail ID? Okay. That was the explain next week.
Yes.
When you'll be completing your CCNA?
2 weeks more.
Like 21st July?
No, after 21st.
Oh, okay. Then we
Okay.
don't have. They'll be start. Okay, guys. Your CCNA takes under like till 21st of this month. Oh, sorry, next month. Okay. So you will
This
be
month.
this month in the viral and all in the like. Okay, so you can start your CCNP from next month, like August month. Okay.
Thank you. Write it down, guys. Students. No. There is one of my student in previous batch. Okay. I told him before completing batch, okay, this is going to start next. You have 1 week time, so prepare accordingly. I've gave them task. I've gave them, this is how first prepare this topics, everything I've given. Okay. The next day he messaged me, sir, I finished the CCNA. What next? The very next day. Okay. Then I was busy in class. I didn't reply. You know what was the message he came? So please respond quickly. These things you should learn while you're going to corporate. I'm not telling that he is wrong or right or anything. So when you are going to corporate, there are certain things you have to behave, especially your HR rounds, manager rounds. They will see all those things, how you're reacting, how you're explaining. And sometimes you might get a opportunity to work with clients abroad. There your manners and discipline matters utmost. Because when client says, I want this person to be assigned in my project, the company can't, refuse it. So if they ask you in the project, then you're the, say, king there. They can't throw you out. So that just not about technical, every aspects comes into picture. The way you sit in interview, the way you answer a question. Whenever I'm telling you, whenever you're going to give an interview, online, offline, doesn't matter. Always try to look at the face of interviewer, especially online. 99.99 people makes this mistake, which no interviewer will like it. Last Friday, I took an interview. That guy answered everything facing the sky. He answered everything like this. He's not looking at me only. Those things, it is a, though he gives an answer, it is a remark. People will not like it. Try to look it on the webcam, try to see the interviewer, right or wrong, give the question. Okay. And if you don't know the answer, try to give them, not sure about it now, but I will learn it later. Like that, your answer should be. I asked, what is router LSA, network LSA? The answer he was given is the LSA given by router is router, the LSA given by network is network LSA. Though, please don't do these mistakes. Okay. Try to prepare it well. See the webcam and answer. Everything you have a mark, which you will not know in front, back and they will filter it. Okay. Written, guys? All right. So in your OSPF, we call this as LSAs, link state advertisement. LSAs. Okay. Link state advertisement. What is this link state advertisement means? It is to exchange information between the device about the network topology. Okay. So if there are multiple routers connected, okay, so I will send my LSA to my nearby router and the other router. Likewise, every router will share their LSAs. That means information about network topology. What are the network I have? What are the network you have? What are the network the other router will have? Likewise, they will exchange this LSAs. So in the LSAs only, they will come to know about the network topology, how the topology is arranged. Okay, that is your LSA. What is LSDB? We have LSDB. That is link state database. That means it is a collection of, it is the collection of LSAs. It is the collection of LSAs. So how many networks are completely there? That will be there in your LSDB, link state database. LSA means like single, 1, 2, 3, 4 routers are there. Okay, I am one router, he is other router, so he will share his LSA to all three. I will share my LSAs to them. So likewise, we will inter-exchange all our LSAs. So all these LSAs together are called your LSDBs. That is link state database. Okay, all right. So we have 5 packets in your OSPF, starting from hello packet, and then you have DBD packet, and then you have LSU, LSR, LSU, and LSA. DBD package means database description. DBD means database description. LSR means link state request. LSU means link state update. LSA means link state acknowledgement. So this is for neighbor discovery, correct? Hello is for neighbor discovery. And LSA means this is acknowledge the receipt of LSAs. Any link state advertisement comes, so he will reply with acknowledgement packet. So what is this DBD, LSR, LSU? We will see now. So your DBD means it summarize the LSDB info, LSDB content to neighbor routers. So in your DBD packet only, the LSDB content. What is this LSDB content? All your LSAs. All your LSAs will be in LSDB, and all this LSDB will be in this DBD packet, and then they will send it to all routers, so that every router will have information of every other network. Any doubt on this? Devidas, any doubt? Okay. And what is this LSR? It is the request for specific LSA. From neighbor. That means, so if there are 4 routers, in one router I have added a new network and I'm not able to reach that network. Through my LSR, I will request that, okay, I don't have this network's information, please give me. That is what? Request for specific LSA. For specific network I am requesting. That is your LSR. LS update means what? He will give the information about that LSA. That is, he will send LSA to neighbors. Send specific LSA to neighbor. Okay. So there are 5 packets. First packet, listen guys. I'll explain you. Here we have 5 packets. First is hello packet. Hello packet is used for neighbor discovery to identify the OSPF neighboring routers. Okay. And then we have DBD packets. Okay. So that in that DBD packets, you will have all the information about LSDB. That means complete network information you will have in LSDB. Then you have LSR. That is specific information of LSR. LSA means if there are 4 routers, in one router I'm going to add any network and I don't have the information of that router, they will ask through LSR. An update will be given for that specific things. And what is this acknowledgement? LSA 7. Counting. Go drink water and come. Hemant. It's okay. Okay. Acknowledge the receipt of LSAs. If any LSA is given through your update, it has updated. So he will acknowledge, okay, I received this LSA. That is your acknowledgement packet. So 5 packets are there. Okay. Any doubt on this 5 packets? LSR, link state request. So there are four routers. Okay. And I'm having complete connectivity. Suddenly I'm adding one network to one router and I'm not able to reach that router. So how I will ask? Through my LSR. I will ask, please give me the information of this specific LSA. Specific network. That request will be asked through LSR. Reply will be coming through LSU. Okay. And then he will acknowledge through LSA. These are the 5 packets. Link state update. LSU means. Okay. This we have seen already. This we have written already. And here we have seen OSPF packets. Hello, database description. I'll upload this. I think I've already uploaded, right? This one? No? Are you sure? I uploaded, I suppose. How many of you opened and saw this EIGRP RIP version? Is there? Then in same thing only, this is also there. Okay, so it's already been uploaded. Okay, so now we have seen, what are the things we have seen? Basic introduction of OSPF, basic routing of OSPF, and then we have seen this packets. Now we will learn states. Okay, and then after learning states, we will learn what is this DRBDR. Okay, and then we'll learn what are the tables in OSPF, and then we'll wind up. Okay. So there are 7 states in your OSPF. There are 7 states. Okay. See, first I said this DRBDR, right? This DRBDR. So first, what is the priority? First, it is go with highest priority, correct? It will go with highest priority. And next one is highest router ID. Correct. If priority is same on every routers, then it will go to router ID. So what is the criteria for router ID? First is manually configure. For example, if I'm configuring 1.1.1.1, that will be the router ID of that router. If I'm not going to configure this, then second one, highest loopback. Okay. If I'm going to configure 55.55.55.55 as the loopback in one router, and that 55 will become the router ID of that particular router. And third one is highest physical interface IP. Okay. So this will become the router ID. Okay. If for example, in my router, in your practical, I will show you without this manual ID and then highest loopback. So physical IP interface will be the router ID. So here I'm not going to configure any priority. So automatically this IP will become the DR BDR election criteria. Okay, I will show in practical, it will become very clear. Okay, so before that, now we'll learn the states. So there are 7 states. I have 2 routers. Okay, so initially the state is in down. Okay, and then he will start the initialization. That means that is called init. That is called one way. One way. Okay, here router ID is not seen. He will send it back the hello packet. First he send the hello packet, correct? And he will send the reply hello packet. So here it will become two-way. So two-way communication. So here your DR BDR election will happen. Election occurs. Here DR BDR election occurs because so in the hello packet he will in the init state he is going to send the hello packet. In that hello packet router ID will be there, but this router's router ID will not be there, right? Only one router's ID will be there. So both will send the hello packets. Now both will have the router IDs and priorities will be set. If the priority is not there, then router ID will come into picture and then they will elect the DR BDR. So in end of your two-way, your DR BDR election will complete. Understood? So how many states we have seen? Down in it two-way. 3 states are over. Still we have 4 states. That is extra, exchange, loading and full. Okay. So now this thing is over. DR BDR election is over. Now we will start with exstart. So here database exchange will happen. That means DBD packets exchange. What packet? DBD packet. DBD packet exchange. Here DBD packet exchange. Okay. For example, he is 2.2.2.2. He is 1.1.1.1. Okay. He will send it the DBD. Why we need DBD? Because inside this DBD only all the networks are there. LSDBs. So he will send the DBD packets. Again, he will send his own DBD packets. Whatever information he has, he will send it. Whatever the information he has, he will send it. So this procedure is called exstart. Okay. Or we are saying this as master slave negotiation. We are saying it as master or slave negotiation. Because whoever has the highest router ID will send the packet first. Here it is 2.2.2.2 is the highest router ID. So he is sending the first DBD packets. If this side is 2.2.2.2, he will send the first initial DBD packets. So that is your master and slave. Who is the highest will initialize. Okay. After that we have exchange. That is so here actually they are sending the empty DBD packets are sent. Why empty DBD packets are sent? Because there only master and slave election happens in your exstart. So they will send the DBD packets and they will come to know he is the master, he is the slave. In your exchange, your actual LSAs will be sent. In your exchange, your actual router exchange LSA headers. That means he is sending the DBD packets. Sending DBD packets. That is your exchange. Okay. So initially it is in down state. Okay, now I'm going to send the hello. Okay, that is one-way communication. And he has sent me the hello. That is two-way communication. Now both have sent the router IDs. Correct? So the DR-BDR election is over. Because to elect a DR-BDR, you need priority and router ID. Now we have the router ID exchanged. So in your two-way states itself, your DR-BDR election is done. After that, X start. So here they are happening the master-slave election. So who will initialize the data? That is DBD packets. So they will send the empty DBD packets and they will start, okay, I am the master, you are the slave. Based upon the router IDs and DR-BDR routers. If I become the DR, then I will send empty DBD, then he will send the empty DBD of his own. And they will come to know who is the master and slave. In your exchange part, the actual LSAs are sent. Actual network, what are the network inside, what are the network there will be sent in your exchange part. And then you have something called loading. In your loading, they will request for missing LSAs. Request for missing LSAs. That means what? Your LSR and LSU will play a picture here. Okay. So all the networks have been added. First, initially, I sent the hello, you sent the hello. That is fine. After that, what happened? I've sent the empty DBD. You sent the empty DBD. Master slave is open. Oh, done. And I shared all my networks with you. You shared all your networks with me. Everything is fine. Now in my router, I have added a new network. Okay. Then what will happen? In the loading state, I will request through LSR and you will give the reply through LSU. So that is your loading state. That means if they ask you in an interview, what happens in your loading state? Then you have to say, so we are requesting for missing LSAs through my link state request and link state update. This is your answer. Usually they'll say, what are the states in Ospf? Then you have to say down in it two-way, extract, exchange, loading and full. Sometimes they will ask you, okay, explain all the states. Or sometimes they might ask you what happens in loading state. So they will request for missing LSAs through LSR and LSU. Likewise, each and every state should be very clear and perfect. Okay. So once your loading is done, now it will come to full. That means what? Fully synchronized. Now the neighborship will form. Neighborship is formed. Okay. So this is the back-end procedure of your OSPF. These are the 7 states. Any doubt on this? Go through the recording once again.
In which state we are requesting for that missing data packets?
Loading.
Loading state.
Yes.
Requesting for missing, that is LSR.
LSR means you're requesting for the missing LSA, and LSU means he's going to update that network through LSU.
Oh.
Request and update.
Means whatever we get as message, we have to update.
Correct.
After requesting.
Yes.
LSA.
Okay. So go through the video once again and write it down like this. Okay.
So every time a new router is added or a new network is added, then only LSU will happen, or is there a
No. You're not audible very clearly. Wait. Wait. Yeah, ask me, what is it?
said like every time you add a new network or a new router, then only this LSU and LSR would happen,
Yeah.
or
Correct. See, whenever you are going to add a network, and if you give the routing, it is not going to ask for link state request or update. And routing is not there in that time. It will not know where the destination is, right? So in that case, these things comes into picture. Okay. I'll show you in practicals now.
is there any particular interval that the synchronization happens, or it's like only when you first connect?
If the synchronization for some network is not happening, that means in one network I've given, the other network I have not given routing. So this side router will ask for request, but update will not come, right?
Yeah.
The update will not come. So he will just leave it. Only the update comes, then he will synchronize complete to full.
Is there any specific duration for this entire process after every so many duration?
I'll show you in practical suite.
Okay.
First of all, now where we are using this DR/BDR? Please pay attention. Very important topic. Okay. I'm having 5 routers. This is 1.1.1.1. Okay. So like this, your topology is there. Here, which router will become DR router? 1.5. You? 1.1. Which one? You? 1.5. Why 1.5? Correct. That means first, what is the criteria for DR/BDR? Highest priority. Here, did I send any priority? By default, priority is there. What is the next criteria? Highest router ID. Now, what is the criteria for highest router ID? Manually configure. Did I manually configure? No. Do I have any loopback? No. Then physical IP is there. What is the physical IP? 1.1.1.5. So this 1.1.1.5 will become the what router? DR router. And for BDR router, second highest. So this will become BDR router. Okay. So this is the criteria for DR/BDR. So now why we require this DR/BDR? For example, there a packet is coming. Okay. What he will do? He has to send to every other router, right? So he will send it to 2, 3, 4, and 5. Correct? That is fine. So now this 2 has received this update, also 3. For this 2, this information is new, right? That he has received from 1.1. So what this router we will do, I got a new information, so I will share it to 3, 4, and also 5. So 3 has received a new information from 1. Again, he will share it to 2. He will share it to 3. He will share it to 4, 5. If 5 has also received the information from 1, so he will receive to 4, 3, and 2. So the information they will send it to send it to every other one. So there is high in bandwidth and CPU overhead also, because it will keep on sending the messages. To avoid this, we are having this DR/BDR lecture. See, in simple, I'll make you clear. Okay. For example, Sandeep is there. So, no, not Sandeep. Today, Hemant is sleeping. So, we'll ask Hemant to come. So, Hemant has some information about networking. Okay. So, he wants to share it to everyone. One option, what he can do? He can individually. Mohammed is sitting next to Hemant, so he will directly tell him. Correct? He can tell it to this guy also. But is it possible for Hemant to go and tell each and every person? No, right? So what he'll do, he'll come to me, sir, I have this information about this networking term. So this will help every students. So he will give it to me. And I will, in the time of the meeting, in the time of your class, I will tell to everyone, so that online, offline, everybody will hear it at the same time. So that is your DR router. So every information will be given to the DR router and also the BDR router. So BDR router is like an assistant. So imagine I have an assistant sitting next to me. Okay. He will listen everything, whatever I'm teaching. Okay. Whatever I'm giving, everything he will be listening. So once I take off, this person will come in place of mine and he will take the class. But until and unless he is just like a student, he is not going to give any information. He will simply stay there. Okay. So what is the purpose of the other routers? You guys. So any information you have, you will give it to me. So I am your DR router. So I will pass the information to each and every student at single time. So that what will happen? He doesn't have to go and tell each and every person at single time. Correct. So the network management traffic will go quiet. So information coming from DR router, the other routers will simply listen and they will not forward it. Okay, if Hemant is giving some information to Mohammed, then Mohammed might think that, okay, this information is not given to Srihari. So he will pass the information to Srihari, but he might already know it. Then what he will do? He will tell to Uday. Likewise, it will keep on circulate without this DR BDR concept. But once the information comes from me, he is also listening. Mohammed is also listening. Hemant is also listening. Uday is also listening. So they're not going to exchange the same information, correct? They'll simply listen and they'll do the thing. So that is your DR and BDR. So if a packet is coming like this, okay, this is your 1.1, 1.2, 1.3, 1.4, 1.5. A packet has come here. So this is my DR and BDR router. Correct. So this packet he will send only to DR and BDR. Okay, this BDR will receive the packet and he will just simply keep it. He is not going to forward it. But this DR, he will send it to this side, this side, this side, and also this side. He will send it to everyone. So that what will happen? They will simply understand, okay, this packet has come from my DR router. This packet has come from my DR router. This packet, it will come to DR router and DR will send it to 1.1, 1.2, 1.3. Those are DR other. So we have DR, DR, BDR, correct? So other routers are called as DR other. DR other. So once this information is passed from this DR, they will simply keep the packet and they are not going to forward it. So it will reduce the full mesh adjacencies. What is this mesh topology? You remember? All devices are interconnected to each other and they will keep on send it. Correct? So it will reduce that mesh adjacencies. So they're not going to forward it to each and every routers when it comes from DR router. Okay. I will show in practical, it will become very clear. Okay. And before that, there are write down tables. In OSPF, we have 3 tables. Neighbor table, database table, and routing table. So here we have list of neighboring routers. And what is the command? Show IP. OSPF neighbor is the command. Then you have OSPF database table. Here you have the list of all networks. That means show IP OSPF database. list of OSPF routes. That means show IP route OSPF. OSPF. Also write down for metric of OSPF. Reference. Reference bandwidth divided by interface bandwidth. Written, guys? Online? Okay. Write down. Reference bandwidth divided by interface bandwidth. What have you written? Module. This one. What is the divided symbol? That's the only symbol I have. Slash you want. Okay. That is, I know that is a division is like this, but here I have only this that way written. Or you can write it down like this also. Reference bandwidth divided by interface bandwidth. Happy, Manshu? Good. Yeah, very good. That is good. See, it is good at least you open your mouth and ask. I want you to be clear. Okay? I'm happy only. Because you know the difference and you're asking. Some people will have it and they don't open the mouth. And while preparing, they will have the confusion. What do you know? They will ask the friend and you will confuse that friend also. So if you have any doubt, you can ask me. Okay? Not a problem. Now you written this. So now I'll show you this practicals. This is the important practicals. This is where they'll ask question in interview. They're not going to ask you what is the OSPF command. Router OSPF 1. You're going to give the process ID and then I'm going to give network wildcard mask area 0. Done. I'm able to ping. That is simple. Where you're technically sound or not, in this practical you will come to know. Okay? Because these kind of practicals, I don't think they will again explain you in CCNP. Sometimes they do. Okay. If they don't do, then you will not understand what is happening.
Kamil, can you show that status messages also?
So what?
Status, 7
What?
states as you connect.
7 states.
Yeah.
Yeah. Wait. So here I'm saying 1.1.1.1. Done. Done. See here, adjacency has formed. Here you can see from loading to full. And you can see loading is done. That means whatever network he has already given to him, and he also given back the LSAs. So now they went through all the 7 states. First initially it was down. They exchanged the hello packets. Okay, DR-BDR election has happened. And then he exchanged the empty DBD packets and master slave has happened. Then he also exchanged the complete network, whatever he has in 5, he has exchanged to 4, 4 has exchanged to 5. And now loading means what? Loading done means he has requested for the any missing LSAs and he has said there is nothing. As long as there is no missing LSAs, it will not be there. Any missing networks, it will not be there. Okay, so that's why from loading, it has become fully synchronized. Okay, now come to this. First, I will do all 5 routers and then I will show you. Done. Now you can see come to this 1.1.1.5. Okay, so this 1.1.5 has neighborship to full, right? With what? 1.4, 1.3 also is there, 1.2 is also there, 1.1 is also there. Correct. Now come to 1.4. He has full loading to full from 1.5, 1.3, 1.2, and 1.1. Correct. But see this 1.1. He has completely full to only 1.5 and 1.4. Likewise, this 1.2 has full only to 1.4 and 1.5. Correct. Why? Because these two routers are DR-BDR. That is the reason they have full connectivity to only DR and BDR routers, not to other routers. To other DR other to DR other, they will have only two-way state. Only down, init two-way, that's it. After that, they will not have any states. Complete neighborship will not be there. In an interview, they might ask you, so what state is it between the DR other and other DR other? You have to say two-way. Otherwise, they will ask you a question, why the DR other and other DR other, they are not sharing information? What exactly happened? This is a very technical question they will ask you. Okay, if you're technically very sound, you can easily answer saying that because the DR other and other DR other, they have only two-way state. Okay, so in your exstart and exchange only, they are exchanging the DBD informations. Correct. So that they will not exchange information between two other, only till two-way they have communication. So only DR and BDR election, they are participating. After that, every information is given from DR router. Because they are not having full adjacency with all the routers. Only if we have full adjacency, then only you can ask for empty DBD packets, your complete DBD packets, missing LSR, LSUs. If the DR other router doesn't have any information, he will always ask it from DR router only. And any information coming to DR router, he will send it to all the routers. That we will see. Now, go to this R7 and say show IP OSPF neighbor. Here, 1.4 is what? BDR router. Other routers are DR other, and DR other. Correct? And where is this 1.5? Because he is the DR router. Check. Go to 1.1.1. Here you can see. Show IP OSPF neighbor. Here you can see 1.5 is what? Full DR. With 1.4, it has full BDR. But 1.3, it has two-way. That means only he is participating till DR BDR election. And it has DR other it is. Likewise with 1.2 is also only two-way. And DR other it is. Okay. Now, so 1.5 is there, which is my DR. Correct? Pay attention. This is my DR router and this is my BDR router now. That is fine. If I'm taking off, that means I make this interface shut. So who will become DR now? This BDR router will automatically become DR router. That is fine. But for this router, he needs another assistant. So now 1.3 will become BDR. Understood, right? Okay, now this is DR, now this is BDR. Now this interface has come up. Again, the interface has come up. He will be DR other only. He will not become DR. Okay, he will be DR only. He will not become DR other. Because already we have DR and BDR. Okay, now he is DR other. He is BDR. He is DR. Now I'm turning off this interface. Router 4, I've turned it off. So he will not become DR. Who will become DR now? The BDR router will become DR now. And election will happen for BDR. So in that case, this 1.5 will become BDR. Okay, I'll explain again. Initially, he is DR router. He is BDR router. Okay, so BDR will always take over the position of DR, no matter what. Okay, so now this DR router has gone down. This BDR will automatically become DR. An election will happen for other routers. So this router will become highest router ID. He will become BDR. Until this, everything is clear. Correct? No doubt. Now, this interface has came up now. Okay. Now, what will be the scenario? He is a DR, he is a BDR. Everything will be fine. He is also up. And everything will be running normally. For some instant, this DR router has gone down. Now, but we already have BDR, right? So he will become DR. An election will happen for BDR. And then he will become BDR now. So he will be in down state. What if this interface comes up? He will simply stay as DR other only. He will simply stay as DR other only. Now this 1.3 has gone down. Now he will become DR. Election will happen again. So if this interface is up, he will become back to BDR. Which one? If it is down, what are the other two routers? Router 1 and 2 are there. What is the election criteria? Highest priority and then highest loopback. 1.2 will become BDR. Likewise, it will keep on happening. Okay, now we'll see in practicals. Theory part understood?
So what if we add, so all links are up? What if there's a higher value of IP that's added?
Ronnie, your voice is very low. Either speak loud or use chat window.
No, I said like if you add another router which has a higher value when all the links are up, then
See, for the initially, whenever you're doing, first time it will take for highest router. And next second highest router, it will take it as the second BDR. If I'm going to insert another router with more highest IP, that is 1.1.1.6, I'm going to add. In that case, 1.1.1.6 will be DR other only, because already I have DR and BDR. Once the DR goes down, again BDR will come as DR. Again, if that BDR goes down, then BDR election will happen, 1.6 will become BDR. Like that only it will happen. So if you want a specific router to be DR every time, simple, increase the priority. If you increase the priority, election will not happen based on the highest IPs, only priority. So based on priority, that IP will become the DR router every time. Okay. Now I'm going to shut this interface.
Okay.
Interface gig 0/0 shut down. Okay. Now see full to down. Full to down it has become state. Now go to R6. Show IP. Now see 1.1.1.3 has become BDR, correct? And this go to this 1.1.2. See, once this 1.1.1.5 has gone down, right? See 1.5 full to down, no neighborship. 1.5 full to down, no neighborship. And then with 1.3 it has become loading to full. Why? Because that is a BDR router. That's why it has become full. If it's an initially it was two-way, correct? Because he was DR other. Now he has become BDR, so it has become loading to full. Now I'll say show IP Ospf neighbor. So 1.4 is what? DR. 1.3 is BDR. Okay. Now what I'll do? I'll bring the state up. Okay. Now he is loading to full with which one? Loading to full, loading to full, loading to full. That means wait. Interface gig 0/0. I'll shut down. Okay. And this one. IP Ospf neighbor. So now 1.3 is DR. Okay. And then 1.4 is BDR. Wait. So IP Ospf neighbor. So 1.4 is BDR. 1.3 is DR. Now what if I make this 1.4 down and I make 1.5 up? What will happen? BDR will become 1.5. No shut. Now I'll make this one a shut. Cisco packet tracer, sometimes it's very slow. So that's why this, before the neighborship is going to form, other router will become DR router. Further, one command is there, that is clear IP OSPF process. If I do that command, then the process will completely take place and correctly it will happen. Okay, but in
Sir, but that router having highest router ID should become this DR now.
No, it will not become. That is the point I was telling you all the time.
Now you are saying it is slow. That is why it will not become.
No, not like that. See. That is big. What I'm saying is this election is happening, right? This election
Yes.
I'm talking about, but the rules are same. Though there is another router added with highest IP, he will become DR other only. as long as we already have DR and BDR. So now, what is the DR? 1.3, correct?
Yes.
What is the BDR? 1.5. Because 1.4 is off. I've turned it off. Now I'll bring up the 1.4. Or let the 1.4 be off only. Okay, 1.4 be off only. Now 1.3 is DR, 1.5 is BDR. Correct? Now what I'll do, I'll turn off this. Which one? Your 1.5. Interface gig0/0. I'll say shutdown. I've turned it off. Now now 5 is also off, 4 is also off. We have only 1, 2, and 3. Correct? Now this will become the BDR. So IP Ospf neighbor. See, DR is 1.3, 1.2 we don't have. That is become BDR. Now I'll bring up this 1.4.
Is there any debug command where you can see each process happening?
No. That I will capture the packet and I'll show you. See, 1.4 I've made it up. It is what? DR. This is 1.4 I made it up, but it is what? DR other only. But it has full mesh adjacency with which one? 1.2, because this is BDR router. Whereas if you go and check in 1.1, it is two-way because that is a DR other. Okay, now you can see 1.1, 1.3 is DR, 1.2 is BDR, and then 1.4 is DR other. Now I'll bring up this also. Here he has become full DR, but it will not happen. This is the problem we have in Cisco packet tracer. It will not become like this. Here what happened? 1.3 has become DR other now. As soon as I bought this 1.5, but it will not happen like that. This is a bug you have. It will become DR other only. What? BDR it will take. BDR is same only. The DR has become 1.5 now. That it will not happen. I'll go and check. 1.5 has become DR and 1.2 is BDR, right? I'll change. Now 1.5 is DR, 1.4 is BDR. Okay. So when this router goes down, the other router has become DR. He will not, this 1.5 again, he will not become DR router. Okay. Here in the Cisco packet tracer, sometimes we are having this bug. In real-time routers, it will not happen. Okay. So now I will show you, I'll capture the packet and show you how they're going exchange informations. Okay. So the something called two multicast address, correct? How they're using this two multicast address, I'll show you now. Okay. So I'm going to add a loopback here. Interface loopback 1. IP address, I will add say 3.3.3.3. Okay. router OSPF1 network 3.3.3.0 0.0.0.255 area 0. Correct? Packet is generated. Correct. Click on this packet. What is the packet it is using? Ronald or Roni, you see?
Yeah.
OSPF link state update. Correct?
Yeah.
Not audible. See, it is using
Yes, yes.
OSPF link state update. That means a new packet has come. So he is going to send it through update packet. He is going to send it through update packets. That is why you see LSU. And what multicast address he is using? 224.0.0.6. Because who is going to listen to 0.6? Check your note copy. Not all
BDR.
routers. It is only DR and BDR routers. So that's why it is using multicast address as 0.6. Okay. Now I'm going to send this. So 1.5 is DR, 1.4 is BDR, correct? These two will take it, others two will drop it because they will not listen to 0.6. Okay, so the new update, LSU update has come that has received from your DR other router and it has came to DR router and BDR router. So both of them will have it now, correct? Now see what is going to happen. Click on this. This is the packet which came. Now send. So he is sending. Who is sending? DR router is sending. Click on this packet. What is the destination? 224.0.0.5. That means every router will listen to this multicast address, correct? Now, check. I will send. Everybody will receive it and everybody will just accept it because it has come from the DR router. Okay. And again, they are not going to forward it. That's it. They are not going to forward it. Only if it is coming from DR router, they are going to take it and keep it. Okay. Now, another scenario I will show you. Now we have seen this in DR other router, right? Now I'll show you. This is the what router? BDR router. So I'll add a loop back here. 4.4.4.4. Okay. Router OSPF1 network 4.4.4.0 area 0. Simulation. Enter. Packet is generated. What kind of packet is it? LSU. Because he is going to update this information. Okay. And what destination IP it is? 0.0.0.5. Why it is 0.0.0.5 here? So this is the difference here. Since it is a BDR router, he himself will send it to everyone. And everybody will accept because it is BDR router and they have full adjacency with BDR router as well. Correct? I've shown you. They are not having two-way state. They are having full. They are having full with BDR router also. See. I'm going to send it. See. Everybody has received it and everybody is going to accept it. Because this packet is coming from BDR router and they have full adjacency with BDR router as well. And they're just going to keep it and they're not going to forward it. If it is coming from DR other router, he will send it to both DR and BDR router via 0.6 because only DR and BDR will understand that. Okay. And while sending the packet, he will use 0.5 destination address 0.5 so that every router will receive that update packet. But when the network is added in BDR router itself, he will directly use 0.5 because BDR router will understand to both 0.6 and 0.5. correct? And he has full adjacency with all the routers, correct? So that he will directly send it. Okay. Any doubt on this? Clear? Please go and do this practicals once again. Okay. Please go and do this practicals once again. Very important. Interview
Sir,
questions are asked based on these topics only.
sir, what is that you told no? DR has full adjacency with all the routers, right?
Yes. That means they are going to do all the 7 states. See here.
Neat.
That is a DBD packet, right?
Correct. See, 1.1 he has full. Where is, no, not this one. 1.4 he has full. 1.2 he has full. 1.3 also he has full. And 1.1 also he has full. So that's why he is able to send the packets. Because only if you have full adjacency, then only you can send the DBD packets. If you have two-way state, you can't send. Correct? Because extart only it starts the DBD packets. Clear, Devidas?
Okay, DR only has this full adjacency or BDR also?
Both.
Both.
Online guys, any other doubt? Ronald, Balaji, Abhishek, is everyone clear?
Yes.
All right. Now I'll show you this database table also. We have seen this neighbor table. So in neighbor table, each and everything you are able to see neighbors 1.1, 1.3, 1.4, 1.5. Now I'll show IP OSPF database. So you have list of all the LSAs. So 7 LSAs you have. Okay, router LSA, network LSA, now ASBR LSA, you have stubby LSA, not so stubby LSA. All those things you will learn in CCNP. As of now, we are learning only one area concept. So in one area concept, we have only 2 LSAs. One is router LSA, other one is network LSA. What is this router LSA? It has the LSAs of each and every router. So this is my 1.5, right? So 1.5 has what are the networks, what are the IPs there? You can see. Okay, a network LSA is advertised only by DR router. Here you can see DR router. That is your network LSA. Okay, so in single area, you have 2 types. One is what? Type 1, that is router LSA. Type 2 is network LSA. So type 1 is generated by all the routers and type 2 is generated only by your DR router. Okay. What's your name? Ah? Zen. Zaid. You know why I asked your name? Good. You know why I asked his name, everyone? Understood? He is more than Hemant today. He was not able to control. Too much heat. That's why you're feeling sleepy. If I turn on the AC, you will sleep more. If I turn on the AC, you will sleep more. That's okay. So this is your database table. Now I'll show you. What doubt? Show IP route OSPF. Here I will see only the OSPF routes. Okay. So you have 3 tables: neighbor table, database table, and routing table. In routing table, you will see only the routes of OSPF. Neighboring table, you will see the neighbors of OSPF, and DR, BDR you can see. In your database table, you can see the LSAs, router LSA and network LSA. Okay. So what is the topic today we have seen? We have seen what is OSPF, basics of OSPF. Okay. What are the conditions, Dijkstra algorithm, metric, link state protocol, open standard, those things we have seen. Basic practical of OSPF. Simple OSPF 1, network, wildcard mask, area 0. Done. After that, we have seen what are the packets. 5 packets are there. Hello DBD, LSU, LSR, and LSA. Okay. And then we have seen 7 states. Each state what will happen we have seen. Then we have seen what is DRBDR, why we require DRBDR. Okay. And then practicals of DRBDR. And then 3 tables. So this is there for your CCNA syllabus of your OSPF. Any doubt on today's class online, guys? Please respond. Offline, any doubt? Go watch the recording once again, do the practicals. Okay. So tomorrow I'll take off. I'm not well. So I'll take off tomorrow. If I'm well, if I'm good, I'll come on Wednesday. Otherwise, most probably I'll come. If not, I'll take off on Wednesday also. I'll inform you in the group itself. Okay. So meanwhile, please prepare. Your routing is over completely now. So switching is of 3 or 4 days class. Okay. So if you have time, don't waste it. Prepare for your interview. Okay. Thank you guys. I'll see you guys on Wednesday mostly, if not Thursday. What is interesting, Ronald? OSPF is interesting.
Yes.
Yes. Actually, it is interesting because little different you will learn compared to your RIP version and EIGRP. All right, good. Okay, guys, thank you.